What's up, Poppy friends? So if you watched my vlog last week and you've been following my socials, you'll know that I've recently picked up a 3D printer and I've been playing around with it for about a week, and I wanted to give it just a bit of insight and sort of just reflect back on what I've learned so far, sort of what the challenges I've encountered, and pretty much that first week of the learning curve of using the hardware. So just a very, very brief intro. I picked up the Elegoo Saturn as well as their Mercury wash and curing station. Now, I've been doing a bit of research and talking with a bunch of friends who also have and use 3D printers, and I settled on the Saturn. It seemed to have the best quality compared with the price point that you're paying for, and it's a relatively straightforward plug and play device. It uses resin, not filament. And then the LCD touchscreen allows for easy opening and loading of files and printing of whatever you're printing. So I settled on this after doing research for probably about a couple of weeks. And then you can wash and cure resin prints by hand. So you can use a toothbrush and either water or isopropyl alcohol. And you can scrub down the models and then you can cure it in the sun. But the Mercury wash and cure station, I know it's in US, but I bought it off Amazon for just under $200. And just expediting or being able to expedite the process of 3D printing, of having a machine do the washing for you and then using the UV lights to cure it, definitely does speed up the process. It removes a lot of that labor. If any of you have ever actually built or modeled resin kits like Forge World, you'll know how just time consuming it can be and how laborious it can be to have to get out soap and water, get all your different bins together, and then using a toothbrush, scrub and clean all of the models. And especially how dirty these resin prints can come out of the machine. It's just far easier to actually have a machine do all the work for you. And I'll touch on the challenges and sort of what I've learned with the cleaning process later on in the video. So getting into it, the Saturn itself is relatively straightforward, pretty much plug and play. Actually setting up the hardware out of the box doesn't involve much more than screwing in the base plates, plugging in the machine, and then booting it up. Same with the cleaning cure, the wash and cure station. Fairly straightforward, very easy to set up. The only exception that I found was the software and firmware. So in order to prepare your STL files and to slice them for the Saturn comes preloaded with a software called Chitubox. And I'll cover more on that software later, but basically you need to use this software to slice up the file and output what's called a Chitubox or CTB file. You can then take this, load it into a USB drive, and you just plug it into the USB port of the Saturn, and you should, in theory, be able to just click print, pick your file, and you're off to the printers. What they don't tell you is that the specific firmware on the Saturn can only read output files from a specific version of Chitubox. And so what ended up happening was, when I installed the software as per the instructions that came with the 3D printer, it loaded in Chitubox 1.8. And then when I booted it up, it gave me the alert that there was a newer version out there, 1.9. So I updated the software, output a test CTB file, and then went to the printer to go and print. And of course, because the firmware on the printer doesn't match the software that's outputting the CTB file, it wouldn't print. It kept giving me an incompatible file format error. Okay, fine, that's cool. So I do a bit of research, and essentially you have to update your firmware. The firmware that you have to download is specific to the model of your Saturn or the 3D printer. And so you have to look at the, there's various ways of doing it, but the easiest way is to look at the serial code on the bottom of your 3D printer, and the website gives you a very nice, easy way to break down the serial number and to figure out which firmware you actually need to download and install. So for mine, I have the PGL screen, so it's this specific firmware version. So you download it, it gives you a zip file, and you'll have two files, the LCD and CVD. Okay, fine, cool. So I take both those files, dump it on the USB drive, and bring it into the 3D printer, and I install it as per the instructions. So you basically go to print, it shows the two files, and you select them and basically quote unquote print them in order. So LCD first, then the CVD file. And in theory, that should update the firmware on the printer. Did that, didn't work. I was still receiving an incompatible file format issue. It took me probably an hour and a half of research and more cursing than I've done in the past decade. But essentially, the sequencing of the way you update the firmware on the printer matters. You have to plug in the USB key first before turning on the 3D printer. Only then can you go into print, pick the firmware file, and it'll update the firmware properly. Incredibly frustrating. This is the one part of it where I think it's not at all user-friendly and it's not very clear on the sequencing. And I actually had to dig through years and years of Reddit pages and technical support answers in order to get the answer I was looking for. So basically, if you're getting this printer and you're using the software, make sure that when you download the software, that you have the proper firmware installed on the printer and that you sequence the firmware installed properly. So printer off, plug in the USB key with your firmware files in the root drive. Once it's plugged in, then you boot up the printer, and then you go and print and you update the firmware as normal. So once you've got the software and firmware issues figured out, it's actually fairly straightforward to then output files and bring it into the printer. Really, all you're doing is you're loading in whatever STL file that you have, you slice it, you output it, it'll give you a CTB file, put it on the flash drive, bring it to the printer, load it in, and the sequencing at this point doesn't matter. The printer can be on or off, you can plug in the USB drive and it'll detect the CTB files, no problem. The sequencing only matters for when you have to update the firmware. And you're good to go. And I'm not ashamed to say that I burned through a kilogram of printing material in the first few days because I was too excited. And I was really just playing around with different print settings, different slice settings, and also just sizing different materials for the scale that I'm going to be using for Marvel Crisis Protocol. Getting into the software itself, so they recommend using, and I think you have to use Chitubox to output your CTB files because unfortunately the Saturn only reads CTB files. As I've understood, I haven't really played around with other software, but I think the software that they give you, Chitubox, is fairly easy to use. It's very user-friendly. It's not a very complex UI, and so I don't think there's any real issues with being stuck using this program. When you first boot up the program, you can go into settings and you can basically set the resolution, basically the size based on your printer. And so the instructions for the Saturn tell you that the X and Y are 3840 by 2400. You plug that in and it gives you the printing plate. So you know that this is the space you have to work with. And then you have a grid here where you can actually set for the width. And so I've done it by inches. So 25.4 millimeters means that each of these boxes is an inch. One of the other learning things that it's a minor thing, and you would think it's kind of intuitive if you do 3D printing. And I kind of wish someone had taught me this at the very, very beginning. So two things. The first is hollowing out your material. Now this object itself is hollow, but if I load in something like this newsstand, so this in itself, a lot of these parts are going to be solid resin. Something like this rooftop, which gets printed out like this, if you don't hollow it out, is printed as solid resin. And the problem with that is it's a huge waste of material and really, really unnecessary. And I actually printed off 2 batches of subway benches and trash cans without hollowing the material out. And it burned through probably 2 or 3 times the amount of material that was probably necessary. So instead of printing it and using, say, 100 milliliters of resin, it ended up using 2 or 250. Also why I ran out of printing resin so quickly. I didn't think to hollow out the material before I printed. And Chitubox allows you to specify this or to perform this procedure very, very easily. You just click the hollow button, specify the width of your walls, and then the infill structure. So you obviously want something in there where it's hollow to print in some support structures. And so you just go grid 3D and you specify the density. I recommend somewhere between 30 to 50 for something like a tabletop miniature. If you need that higher density for something that requires stronger structural support, you can go higher. But I've been using 40 to no problem. And then you just hit start. You make sure you have your object selected. And it'll run the hollowing process, and it'll show you as it hollows out all of the material. So that was the first thing that I didn't think to do until I printed off this newsstand. The second is the fact that water washable resin can crack. And I think this is a combination of just the material itself, the thinness of the material, and then because we're printing in a hollow fashion, and we're not able to UV cure the internal structure of the actual print, that as it dries, it causes the material to expand and essentially, I don't know what science is behind it, but essentially it cracks. And this is basically because of the thinness of the wall not having the structural integrity required to keep the material intact. So you can actually see, and I posted this on my social, I'll try and get it to focus on the camera. But on the side of the news box, essentially, this is over the course of 3 days. It started off with a hairline crack in the center, and it's essentially cracked all the way to the front. You're not seeing this issue in the roof of the newsstand, and I think that's because it's a thinner, denser object, and the internal structure is able to hold it together. Whereas something like this larger area where it's thinner on the inside, not enough support structure to hold it together, the resin as it cures and dries is causing the material to expand and crack. So I think moving forward, I'm going to start having to do thicker walls, use a little bit more material, especially for larger objects where I'm hollowing out to prevent this cracking. The other thing that I didn't think to learn or to plan through was the amount of material a print requires. So when you go to slice a file to output for printing, Chitubox has a very, very unique feature. If it'll actually print, or if it'll actually slice.
A little longer than a few minutes later.
No, we're going to try this with a smaller file. So when you go to slice an output file for 3D printing, it tells you exactly the volume and weight of what you're printing. And you would think to basically load in or make sure that you have loaded into the printer enough material to print whatever it is you're printing. I obviously didn't pay attention the first few times, and I ran a print overnight, and I didn't think to double check that I had enough material loaded into the printer to print the file that I was printing. Surprise, surprise, the file failed to print. I only had about half the material I needed and essentially failed. So it wasted about, I think, 150 milliliters of material, which works out to be about like $5. I mean, it's not a big deal. I think it's one of those things, those mistakes that you have to make the one time and then you never do again. And what I've done is essentially used a measuring cup that has milliliters on the side, and then using water, I've pre-measured on a red cup the exact increments for 1, 2, 3, and 400 milliliters. Now, obviously, I don't want to pour the resin into a measuring cup that we also use for food, hence why I just used water. And then every time I need to pre-measure some resin, I can just take a red cup, transfer over the markings for the exact quantity I need, and then pour it into the plate. The plate itself also has a maximum fill line, and I know that half of the reservoir is about 200 milliliters. So for the most part, I can eyeball approximately how much to pour in and leave into the printer so that when I'm printing, which I think for the average print sits around 150 to 200 milliliters, I know exactly how much to load in now. But it's something I wish someone would have told me, just so I wouldn't have to make that mistake and waste that initial quantity of resin. But otherwise, I think those are really the biggest challenges so far that I've encountered in the learning process. The last step, once you've got the stuff printed in your 3D printer, is to actually clean it. Now, there's a wide variety of resins out there, and for the most part, and as I can understand from my research, the higher quality resins tend to require cleaning chemicals to clean them. So whether you're using isopropyl alcohol or IPA or some other cleaning material, you have to have some other chemical to clean them. Because I am just starting, and also because I have a lot of animals in the household, my first thought is to essentially reduce the amount of chemicals I'm using first as a means of cost. I'm not paying for chemicals, add an extra step to clean them. It's also easy because I can just use water. It's less toxicity because of the mixture in the cleaning process, as well as disposal. And there's less fumes being thrown in the air and just have sitting around as it's cleaning. So safer for me, safer for the animals. But the issue that I was having, just using straight water in the wash and cure station, was that it wasn't getting the material as clean as I'd hoped. What I've been doing so far is essentially, once it's printed, I shake off most of the excess resin. I remove the supports, and make sure you're wearing PPE for this. It does get very, very messy. And then I dunk the resin into the washing station, and I'll do 2 wash cycles. I'll wash it once, get most of the resin off. I'll empty the water and then run another wash cycle with cleaner water. Usually I'll do it, depending on the quantity of resin, anywhere from 5 to 10 minutes for each cycle. And then I'll do a UV cure cycle, probably 8 to 10 minutes to make sure I get all the sides. So depending on the object, sometimes I'll have to rotate them or put them on the side to get like the bottoms or the tops if I can't cure them the first time through. So the issue that I was having with this process was that it was leaving, I don't want to say it's a tackiness, but in handling the material, it doesn't feel clean. And so talking with one of my friends, shout out to Jacob, he recommended his process, which was essentially to use a tub of hot water, do a dunk in there, clean off most of the surface resin, and it also makes the supports easier to break off. Once I've done that dunk in hot water and I've cleaned off most of the resin, he's recommending to use not water, but something like mean green or simple green, which is a very basic, very over-the-top household cleaner. Use that in the wash and cure station instead of water. And then once that's done, rinse it off in cold water, give it a quick scrub with a toothbrush or whatever, and then cure it. I haven't had a chance to try it out yet right now because I am currently out of resin, but I have some resin coming in probably in the next couple of days. So once I get that, I'll give it a try and see if that improves the process. And that's pretty much the only part where I'm having issue now, and where I want to dial in with my further experimentation is the cleaning process to get the resin super clean to a point where it doesn't feel tacky at all and it is paint ready. Insofar as experimenting with other resins, I'm actually really enjoying the one I'm using right now. It is the frozen water washable gray resin. and I think their black resin is equivalent, so swapping between the two isn't an issue. I've done a bit of research into other brands, so Elegoo's, eSuns, and Monocure, and everything I've read about those indicates that when cured, they are more brittle than frozens. So if I can find them at a decent price point, I do want to pick up some of the other brands just to try it for myself and see what the output is in terms of quality versus the trade-off in brittleness, if it's really even a noticeable difference. But so far, I'm having really, really good results with the frozen one. I think the actual quality of the model will have more of an impact in terms of visible layer lines. What I've done so far in terms of the settings is having a layer height of 0.03 millimeters. And this is the minimum layer height that they recommend for this resin. So the output file that you're getting, it doesn't actually have really visible lines. I printed this new stand with the curves, and I honestly can't tell at all. Although when I painted the subway bench, it's an angled back, and on that one, the lines were a little more noticeable. So I think maybe it's an issue of curves versus diagonal lines that's creating those print lines. But for the most part, I think a bit of light sanding, and once you get your primer on there, it's not really even going to be noticeable. But if you're going to be printing models that you're going to be casting or miniatures for things like painting competitions, not necessarily for tabletop models, that may be a limitation of the water washable resin, and where you may want to switch over to something like Frozen's 4K resin that can print in super, super thin layer heights to completely reduce layer lines. Of course, and the downside is they're not water washable, and you're going to have to introduce other chemicals in the cleaning process to actually clean the material. But I think for now, as I'm learning and as I'm experimenting with it, I'm going to stick with water washable resins because they're working for me. I think that's pretty much it. This was really my first week of using the printer. There were a few birthing pains at the start, particularly with the software firmware, and then not printing hollowed, and then when printing hollowed, having too thin of a layer wall. But I think moving forward, I've basically nailed down the process, and it's more just fine-tuning the little things for just improving the quality, or maybe optimizing the speed somewhat to make the prints print faster. But really, I think I'm now able to take STL files from wherever and print them up, and it's going to open up a lot of possibilities in terms of my hobbying and my model making and scratch building projects. That's it for this video. I hope you enjoyed. If you're thinking about getting a 3D printer, or if you've got one and you're just starting, hopefully I'm able to give some insight into some of the mistakes that I made in the beginning and that you won't make them, having learned from this video. If you want to check out my other socials, I'll drop a link in the description below. Till next time, as always, happy hobbying.